Good evening, all. Am I
Audible,
audible?
yes,
Good evening, sir.
Am I audible?
yes, sir.
Yes, sir.
Okay. So let's wait for 1 or 2 minutes if somebody is joining. Otherwise, we'll start it.
Fine, sir.
Are my slides visible?
Yes, sir.
Fine. So, good evening, all. So, I am Yogendra Narayanan. I am a Prime Minister Research Fellow in the Department of Civil Engineering at IIT Bombay. So, I will be, this is essentially a problem solving session, or I would like to say it is an interactive session for the course offered in NPTEL of Geotechnical Engineering 1. So, under Professor D.N. Singh. Uh, so, essentially, to give a brief idea about the uh, purpose of this problem solving sessions or interactive sessions is that the to revise the weekly content that has been uploaded in the NPTEL website and make the learners accustomed with the concepts, and it also serves as a practice session to solve some of the numericals, at least not in the uh, s- few weeks of the course, since it is this first week is an introductory course, introductory introduct, introductory content. So as we move further during this as the during the course, it will be more of a problem solving session, and you can get your doubts cleared both in how to approach a problem, how to uh, any lack in concepts, concept clarity, or uh, solving any problems. Both I will be solving any uh, from various sources and various previous assignment questions. And also, if you have any doubt, you are free to discuss your queries with me. So with this, uh, I would like to know the learner's introduction and what is your background, so that I can face my uh, lecture. I can pace my sessions accordingly. So, can you introduce yourself? Please tell me your name, from where you are, where in the sense from. Uh, are you an undergraduate or postgraduate student, or and from uh, or any interdisciplinary department? Uh, so it is. I'm essentially expecting a brief introduction of yours. So please switch on the mic one by one, and please introduce yourself.
Good evening, sir. My name is Krishu, and I am from Civil Engineering Department from Punjab Engineering College, Chandigarh.
Okay. So you are in third year.
Yes, what you said, sir?
You are in third year.
No, no, sir. Second year, fourth semester.
Okay, fine, fine. And Mr. ARV.
Sir, good evening,
Yeah,
and
good
others
evening.
also. I am Abdul Rafi. I think last year also I attended your session.
Okay,
I am actually faculty, senior faculty.
Fine,
Senior
fine.
in the sense, I have completed my master's degree long back in 91,
Okay, okay.
and
So,
I couldn't make my doctorate degree,
okay, okay.
but I'm a faculty earlier. Right now, I'm self-employed.
Fine, fine.
Just for to be in a continuous touch with the subject, I am interested in geotechnical related courses. Therefore, I
Okay,
used to write every time the exam.
okay,
And last two attempts, I got 98 as well as 99 also.
okay, okay, fine. So you will be
So
familiar with the contents and everything, I hope.
yes, sir, yes, sir. But still, there will be some new questions. Something will come, and then some topics will be new for me.
Yeah, yeah. At
Even in
least
the
in
first week,
initial sessions, it will be a kind of repetition. So, but
yes, sir, yes,
as we
sir.
move forward, it will be quite interesting.
But
But
still, in assignment one itself, I find some new questions in geology also. That's why I asked for some source of the books for geology also, because the books you have mentioned is only about geotechnical
yeah,
and
yeah.
foundation,
Hmm.
but geology books are not mentioned actually.
Okay, fine. And your background is, sir?
Geotechnical, sir.
Okay, okay.
Mine
Okay,
actually in master's degree it is given as a foundation engineering.
fine, fine. Okay.
So I am interested with the subject. That's why every time I attempt the course of this geotechnical.
Sure, sure. It's nice to hear. So, Mr. Direction?
Sir?
No, next,
Direction. Okay,
next,
okay.
next.
Sorry. Hmm.
Good evening, sir.
Yeah.
Good evening, sir. Myself, Direction. I have completed my graduation in 2014 in JNTU, Coimbatore, Telangana, sir.
Okay,
So
okay.
now I am doing as a lecturer, secondary college. What I will do, I want to improve my subject knowledge in geotechnical engineering due to I am interested in geotech.
Okay, okay.
So that's why I enrolled in this center.
Okay, okay. Next, Miss Kritika. You can switch off your mic. Miss Kritika? Hello? Am I audible?
Yes, sir.
Yes, sir.
So, uh, Miss Kritika, you can introduce yourself so that uh, all can know. Okay. Miss Purnima, you can introduce yourself, give a brief introduction and your background so that I get an idea and I can pace my lectures according to it. Miss Purnima? Okay. So, some of the new people have joined. So, only one request is that please try to join in time. So, because it necessitates an unnecessary delay. Okay, sorry. So, Miss Niharika, you can switch on your mic and introduce yourself.
Good evening, sir.
Yeah,
I am Niharika from Mongol.
okay,
I am studying third year civil department.
okay. And Mr. Ashok? Hello, Mr. Ashok, please introduce yourself and give a what is your background uh, and uh, which year and what stream are you from?
She typed in the box, chat box.
Uh, sure whether he's able to hear or not.
She's having some mic issue, it seems.
Okay. Mr.
She's
Ashok,
first year. Yes.
Mr. Ashok, you can switch on your mic and speak if possible. Okay, I think the other two have entered the details in the chat box. So uh, we can go into the lecture. It might be so. This is essentially an introductory lecture. So I would like you to I would like to give a brief glance of what happened, what is the content of the courses, and why uh, uh, content of the contents that has been covered in week one. And this week one is essentially a uh, preface of what you are going to study in the due course of time in this course. So, and essentially it starts with why we want to study geotechnical engineering as an important subject to become a well qualified civil engineer, and it is one of the most uh, misunder, misunderstood stream, I would say. So most of them would uh, most of them would name it, think it's tougher or something. So which I don't agree actually. So with this, I will go into the. I would like you to give a brief outlook on the what we study in this course and what has been covered in brief. And based on the contents covered, there are some questions which I would expect you to get engaged and answer me. And also you can ask your own questions from this week contents also. So first of all, as you all know, civil engineering is essentially started, or it has evolved uh, to sa- to satisfy the primary concern of the people, that is to improve the lifestyle of the people. So in that thing, most of the infrastructures that has been developed in the realm of civil engineering, the most important uh, aspects which we consider is the foundations, or the space where this infrastructure stands. So that is what essentially geotechnical engineering means. So, and since some first year students are there, you might not have uh, that much uh, familiarity with the importance of this. Maybe second and third year students and other seniors get uh, might have a bit of idea what does it mean exactly. So aspects related to the ground, and I would like to uh, in my in my phrase I would like to reframe uh, famous Abraham Lincoln's quote of democracy, like that. Similarly, geotechnical engineering is for the soils, and by the soils. So various aspects of geotechnical engineering we deal. Uh, for example, if we design a building, so that is based on uh, the properties of the soil, on the which the buildings are on the soil. And for the soils essentially means some of the ground improvement techniques which we will be, uh, at least not in this course, you will be studying further. So in order to improve the properties of the soil, we have some techniques. So those are, that is for the soils. And by the soils is that apart from this conventional construction materials like bricks and uh, steel, concrete, etc. There are some structures which have been traditionally constructed by the soils itself. For example, earthen embankments, uh, uh, dams, earthen dams. So these are essentially constructed by the soils. That is, by using soils. So for that, the entire geotechnical engineering is divided into two major bifurcations, which is soil mechanics and second is foundation engineering. So now we'll be studying soil mechanics. So why soil mechanics? So you would have studied various as a prerequisite. It is solid mechanics and fluid mechanics, and this you have first this course soil mechanics offers an understanding of the material itself. So what does it comprises of, and what are all the uh, components that are present when you consider mass called soil, and uh, how to classify them, and what are all the parameters that are used to classify them for our applications. So in case if this uh, realm of soil has been uh, worked upon by various streams, for example agriculture and civil engineering and earth sciences. They are This concept of soil mechanics is approached by several streams. So we will be approaching it from a civil engineering point of view, and the necessary concepts from uh, civil engineering that will be useful in the classification of soils, and further to establish the properties of the soil. So in this regard, the essentially the properties of the soils are of two types: uh, index properties and engineering properties. So index properties uh, is used to classify the material itself. What type of material is it? What are the sizes? What type of shape? And what is the mineralogy? What is the uh, uh, how the soil is, whether it is granular or cohesive or uh, that is very sticky, plastic, etc. So these properties are known as index properties, which define the material itself. And based on this property, we have some uh, we derive some engineering properties which are useful to design the structures according to the necessity, and how these several different type of soils will behave to the external loads that are applied. The loads in the sense it can be mechanical, it can be chemical, it can be thermal, it can be biological, anything. So I hope I'm clear, right? If you have any questions, you can interrupt me in between and you can ask. Please respond.
Sir,
Yes.
sir, what you are discussing with us, will you get questions at the end of the examination?
Yeah. So you will not get the same questions. You might expect a question similar to this.
Conceptual, it's based on the conceptual theory.
Yeah.
I think, okay. For this session, will you give attendance for us, sir?
No, it is not like that. So it is based on your interest. You join and try to solve some problems. It will be a useful session for you to be in touch with the concepts and uh, problem solving. So
Okay, okay. Thank you, sir.
which will be useful. So with this, this is the overall view of why the soil mechanics is an integral part of civil engineering. And in this week, essentially the topics covered was formations of soils, process of formations, and how these processes are classified, and what are all the different agents that play an important role in the formation of these soils, and what type of soils uh, are formed based on uh, different phenomena that takes place in nature. And this is the essential content that has been covered in week one of this course. And as far as some book suggestions, these are R.F. Craig is the primary reference book which we will be following. And also you can, there are some, you can get a copy or this one. And these four books will give you a fair idea of concepts in soil mechanics and as well as in foundation engineering. Gopal Ranjan and A.S.R. Rao, Basic Soil Mechanics, and Soil Mechanics by Lambe Whitman, and by one more book by Mitchell and Soga. So you can note down these book suggestions and you can follow uh, whichever you find it uh, suitable or you find it easy to follow. And also apart from these lectures, if you go through these books, you can enhance your knowledge further. So and try to solve some of the real life problems that are given in those textbooks also. So with this, some questions I would like to uh, I would expect the participants to engage in interactions during this discussion of questions. So this week's we will not be solving any problems. So we will be discussing some of the questions are based on the discussions, theoretical discussions that have been taken place in this week. So first question is, uh, so it is fairly simple. Geotechnical engineering deals with the changes that occur in option A, atmosphere, option B, geosphere, option C, troposphere, and option D, thermosphere. So, any answers?
Sir, we are unable to see your slide, sir. What you are saying, we are unable to see your slide.
Okay. Now, are you able to see?
No, sir.
Just a minute. Now,
Yes, sir.
Yes, sir.
now are you able to see?
Yes, sir.
Yes,
Fine.
sir.
Yeah. So, the question number one is, geotechnical engineering deals with the changes that occur in option A, atmosphere, option B, geosphere, option C, troposphere, and option D, thermosphere. So, any answers or
B, sir. Geosphere.
so? What does geosphere consist of?
It's related with the earthness completely. Earth and rock.
Not only earth and rocks. So, earth in the sense it includes everything. So, the entities that comes with the earth. So, it may be uh, it may be soil grains, rocks, water, groundwater, uh, uh, and the
Solidified form of minerals, everything.
yes, everything, and even living organisms which indirectly contribute to these formations. though they also come under geosphere. So there is a separate branch of research in geotechnical engineering, which uh, which is known as biogeo interface. So in this area, what people do is they try to understand how uh, biological aspects of biological aspects, that is microbes or any other uh, um, plantations or roots, how they interact with the
Is it for agriculture purpose, sir?
both for agriculture as well as some in ground improvement also.
Okay,
So
fine.
if you if you consider, there is a separate research area known as microbially induced calcite precipitation, so which they make use of bacteria to induce the strength of the soil, to improve the strength of the soil. So these aspects, everything deals with geosphere. Uh, so so even in this, a lot of research is being uh, conducted, and by the time you complete this course and you complete the degree of, or if you want to pursue higher studies or anything, it will be a uh, uh, very interesting topic to pursue on. So a lot of research is going on in these aspects especially. So I hope I'm clear. Any doubts?
Sir, in which project they are using, sir? Actually, this one? Am I this one? Whatever you told just now.
Actually, these are at the developmental stages. So
Okay, not yet implemented.
they are trying to, it is in the research stage only.
Okay,
So
sir.
most of them are in laboratory skills.
Okay, sir. Fine.
Any other questions?
Sir, I have a small request here.
Yes,
In the introductory chapter about soil formation and everything,
yes.
the previous NPTEL courses also they cover related with the soils of our origin. That means only for Indian country.
Okay.
But I am interested a little bit if you add in some other special soil which we don't have in our country also. For example,
Hmm.
alluvial soils is most common in our country,
Okay.
but that may not be present in some other area, some other places.
Yeah, yeah.
The same thing if you take a Evolian soils, only Rajasthan and some part of India we have, but it was dominating in Sahara Desert, Libya.
Yeah.
Something like that. If you have some other special soil which we don't know in India, one or two,
Okay.
if you mention also, it will be fine for us.
Okay.
That's also the small suggestion.
Sure, sure. Uh, so there is while there is as we move in this session itself, there are some aspects which I will cover. So maybe I will add in that. Uh,
Okay, sir.
okay. So moving to the next question. So indicate which of the following situations in real life would be falling in the preview of geotechnical engineering. So option one is laying of foundations. Option B is understanding the underground uh, groundwater flow paths to understand the suitability of soils for desired applications. And D is all of the above.
Option D, sir.
Option D, sir.
Yes. So uh, let's read the answer. So let us discuss the other options. So first of all, the first option is straightforward, laying the foundations. That is the primary, as a civil engineer, that is the function, primary reason why we are learning geotechnical engineering. That is fairly straightforward. And B is understanding the underground water flow paths. So why do you think it falls under the realm of geotechnical engineering?
I think it is mostly related with the hydraulic structures and its applications, and then
Okay,
dam sheet piles,
that is
wells.
understand. Any other
Sir?
things? Yeah, any other things?
By this, you are going to know soil permeability, like that. So, if you know that properties of the soil, according to that, you are going to the laying of foundation. Based on the requirement, you are going to for different types of foundation.
Okay, you are connecting the options A and B. So let me come to that
Sir,
also. Yeah. Any other?
Even in well hydraulics, tunnels, deep excavations, trenches.
Yes. So underground water flow paths. That is essentially you need to please switch off the mic. There are some noises. So laying of foundations is fairly straightforward, but what we are going to do by understanding groundwater. So as a geotechnical engineer, so you need to understand the effect of water on soil properties. So whether either it is static or it is flowing. So one of the aspect is uh, soil erosion. That is also one of the aspects which are which needs to be considered if you are working in a uh, in, in projects related to water bodies. And as some of them mentioned, hydraulic structures like dams, you need to understand and establish the stability of dams, uh, which can be which depends on the water levels and flow paths beneath that. So that we will be studying in this course further. And retention structures. So how much uh, uh, so there are some phenomena that makes the soil very weak and make them lose their strength, which are related to the flow of water. So water is a very, if you go deeper, as another person mentioned, well hydraulics. Uh, Everyone in their homes have a bores through which you draw water. So what is the effect of drawing water on uh, stability of the ground? So that is also an important thing to understand. And if you go further deep, so not only underground water, if you start extracting oil from deep formations, so that also is indirectly related to this flow paths uh, and concepts similar to that. I hope I'm clear. Any doubts?
It's clear, sir.
So the third option is to understand the suitability of soils for desired application. So can you give some examples, or what do you understand by this statement?
For example,
Yes.
in case of dam itself, we are going to use a two different material.
Yeah.
Even though structure is only one,
Yeah.
in the core we are using a impervious material like a glaze, which has a permeability of very low.
Mm-hmm.
In the same dam, we are for draining of the already collected water. We are going to use the pervious materials.
Yeah.
Filters we are using a pervious materials.
Mm-hmm.
Like that, we are going to choose the different materials for various applications.
Yeah.
For
So
example, if we take a peat,
mm-hmm.
definitely we avoid. We don't use it almost everywhere.
Yeah.
Something
So
like that.
yeah, good. Any other views?
Even backfill material as a retaining wall in the retaining walls
Yeah.
for construction of the embankments,
Mm-hmm.
roads, even making of the artificial islands.
Yeah. So
Almost many applications we are using a soil.
yes. So any other? So now, uh, as one of our participants mentioned, these are conventional applications. That is uh, for example, if you are constructing a filter to collect the drained water, so it requires a separate uh, aspects of soils that are perfectly suitable for that application, which you will be studying. So it is just to give a brief idea of it. And if you want any structure to be impervious, so you have to choose the materials that are choose the type of soils that are suitable for that. And there are some type of soils which are used as slurries for several applications. So and some soils of certain mineralogy are used for uh, uh, disposal facilities, so which require almost no passage of contaminants or any other undesired components. So either it can be nuclear waste disposal facilities or municipal waste disposal facilities. And you might have seen everywhere landfills and things. So usually they in landfills where they dump the municipal solid waste, they construct a liner, so which are essentially impervious. So these are some of the applications where similar type of where soils are used for different applications. So uh, now how this course will enable you to understand this different understand the suitability for different applications is that you will be studying what parameters govern this. Am I audible? Hello.
Yes, sir. Permeability mainly.
Yeah. So what parameters governs this? So that is what you will be studying, and what is the how to measure them and how to use them in our how to use them in real life to predict these phenomena. So that is the uh, primary aim of this course. uh, as an engineer, it is as we are all engineers, so we need to quantify everything, so we cannot qualitatively decide. So that is the major reason which why we study this course. Coming to the third question, so the domains other than civil engineering where properties of soils are studied or utilized are A. Agriculture, B. Pharmaceuticals, option C. Cosmetics, and option D. All of the options, all the above.
Can you change the slides, sir?
So, has my
At least
slide
move.
not changed?
No, still it is showing question number one and two.
Okay, just
Yeah, fine. Now it is fine.
now.
Yeah, it's fine, sir.
Okay. The domains other than civil engineering where properties of soils are studied. A. Agriculture, B. Pharmaceuticals, option C. Cosmetics, option D. All the above. Any views?
Hope agriculture is already finished most of the time. Remaining are undergoing, I think, B and C.
So, what what is the final verdict? Which option do you
Final
choose?
This question is almost new for me. It looks like option A. Which
Okay.
domains other than civil engineering or computer science are studied or studying, sir?
Are studied or being studied, anything.
Okay.
Are
Looks.
utilized.
Mhm.
Okay. Any
Utilized
other?
means it will come all the three. But
No.
studied means maybe option A will come.
Studied in the sense this in the context of this uh, uh,
We have agriculture map of soil in which they have already
no,
made a
these
lot of work.
some of the properties which we study here are utilized in other fields also. So that is the uh, context the question was framed. So any other views? Any other person? I think only one person is answering. Others?
Cosmetic except calcite, the calcite. Any other they have done, sir? Cosmetics.
Okay. So let us go by options now.
Okay.
So first is option A is agriculture. So agriculture, as you all know, without knowing the properties of the soil, you cannot do anything. So main agriculture, what are all the properties which we consider is water holding capacity, mineralogy, and what type of nutrients they have. These are the primary aspects which we consider in terms of agriculture. So that for which the soil needs to be studied, and some of the tests uh, in geotechnical engineering has been adopted from agriculture. So in agriculture, the subject is studied as soil science, soil physics, soil chemistry, and but we apply those concepts here also to an extent. So agriculture is a straightforward option. B is pharmaceuticals. So you will be studying a property of the soil known as which will be introduced to you to be surface area of the grains, and several applications of for example, you might have come across fly ashes. So some of the byproducts of fly ashes that are not byproducts which are modified from fly ashes known as zeolites. Those are very fine particles which are highly active. So they have higher absorbing capacity. So these are utilized to an extent in pharmaceuticals, and this is how the realm of soil mechanics has expanded over a period of time. And this is an option. And C is cosmetics. So cosmetics, uh, I hope most of the people have heard multani mitti, right?
Yes, sir.
So what does it do? Why we apply it?
What is that, sir? Actually, you use the word of Hindi. What is
Yeah,
exactly English word of that?
it is multani mitti, right? So it is essentially fine soil.
Hmm.
It is bentonite, nothing but
Okay.
bentonite,
Maybe
very fine bentonite. But why we use it is that it has a,
maybe
yeah, tell that.
it fills the
Hello?
pore space the excuse me.
Yeah, it is not essentially pore
Maybe
space.
the re, maybe the we reason using for the fill the pore. That means a small hole in the face.
No, that is not essentially pores. Those are
Okay.
uh, in soil. You don't have what to say pores within the
Maybe
grains.
we sorry. Okay. Removing of impurities right means rubbing.
Yeah, so removing impurities is dependent on how active the soil is. So how
Okay.
the more the soil is active, more it will absorb the impurities, moisture and everything. So that is the aspect which we will be studying shortly. As in second or third week, you will be introduced to it as activity of the soil. So in that aspects, you will be introduced to how uh, how the properties or which property governs the activity of the soil, what makes the soil more active to external agents. So that is also the and also talcum powder. Talc is a kind of it's a powdered rock. So that is also being used in cosmetics. So that also comes under the realm of soil mechanics and under the properties of the soil. So the option will be all of the above. So any doubts, any questions, any clarifications required?
Sir,
Yes.
is it indication that they have already studied or still it is going on?
Here the properties which we study in soil mechanics are also being used by these disciplines.
Okay.
So that is the uh, uh, that is the basic context for framing this question. So
Mhm.
if you see in personally in my lab where I work, so people have studied. We get samples from all over uh, country. Different type is where I work is essentially a geotechnical engineering lab, but the
Okay.
type of tests we do are on different materials. So what I mean to say is, as far as now the present time period is concerned, so there is no particular division which essentially restricts us, such as soil mechanics. So, and also one of the reasons I would like to uh, introduce you to some of the latest developments that are being that are being carried out in the realm of geotechnical engineering also along with this interactive sessions. I hope it will be I hope it is okay, and I feel that it will be useful for the undergrads and uh, maybe faculty members to take up research or take up further higher studies further, and you can explore more options also in industries also. So going to the next question, uh, this is essentially uh, a straightforward question. Which of the following, it is straightforward from the lecture. So which of the following activities require transportation of huge amounts of soil by
Sir,
human
for
beings?
question three, answer is D, na, sir.
Yeah, it is all of the options.
All of the options are mentioned.
Yeah.
Okay.
So which of the following activities require transportation of huge amounts of soil by human beings? So it is obviously both A and B. So if we take first options, formation of artificial islands, so it will be the dredging materials. I hope you are aware of dredging. Please switch off the mic, vehicle sounds and background. If uh, and when you are answering, please switch on and answer. So, have you come across the term known as dredging?
Yes, sir.
What is dredging?
Removal of the increasing of the bed level of sea
Yes.
in case of sheet piles.
Hmm.
One side we are going to increase for actually transportation of these ships and everything. We need to
Yes.
increase the bottom depth.
Hmm.
That is normal. Removal of the soil and reusing in some other locations
Reusing in
is,
summer. Most of the
yeah.
artificial islands where it needs to be dumped in a single locations. So people use from as well as mainland as well as the dredged materials also. So that requires if you are from a coastal city, there will be regular dredging that will be going on every 6 months or every 6 months. I think so. There will be large barges which will be carrying tons and tons of dredged material from near the shore, and they drop it in offshore. Uh, further farther from the shores in order to create the navigation channels. So essentially that is the practice. But if if we consider the formation of artificial islands or artificial lands, which now India is more interested in that case, several materials has to be transported to the particular location, and it has to be placed in such a way that it has necessary strength and other essential parameters. So that is obviously an option. And development of infrastructure is a no-brainer. So it directly uh, comes under the umbrella of this question. So that is it requires transportation of huge amounts of soil by human beings. If you see, for example, if you consider construction of a tunnel, so whatever the as the construction proceeds, whatever the muck that comes out has to be transported, and it has to be disposed somewhere. So that obviously comes into this realm. And if there are large scale excavations going on, the excavated soil has to be taken away from the site and stored somewhere, and maybe it may be used, may or may not be used as backfill material. So this also comes under uh, this activity of transportation of huge amounts of soil. So the option will be both A and B. Hope I'm clear. Any questions? Any queries?
Sir, a
Yes,
small
sir. Clear.
small clarification needs, sir.
Yes.
I think for most of our infrastructure construction, either you take highways or retaining walls or elevated structures or whatever may be,
Yes.
wherever you are using as a backfill material,
Yes.
we are depending on soil from various sources. One is in the coastal area, it's called dredged material.
Yeah.
Whereas if you see the other areas other than the coastal area,
Mm-hmm.
and the soil we are bringing it by cutting it of most of the hills.
Yes.
One answer for that is because of that material will be matching with the whatever requirement for us.
Yes.
But what is the effect of completely cutting off the natural hills? It is actually God has created everything for some purpose. Rivers already we have a band, and now we should not use any material from the river like that. They have already taken care.
Yeah.
But what about this material? What is the effect of cutting up the hills and using it for our infrastructure? Nobody will ask. We are
Uh,
using it. What is the negative point of that?
so it, it is a fairly political questions, I would say. So I will refrain from answering directly. But
Okay.
as far as your question is concerned, I would like to give an opinion from research point of view.
Okay.
So as you said, there are negative effects of obviously negative effects of cutting down hills. So nowadays, if you see M sand, P sand, everything is cutting, which are used in regular real life for as aggregates. So there's those are those are cut down from hills. So now the major research that is being taken over by both geotechnical engineering fraternity as well as construction materials fraternity is there any alternate aggregates alternate material for aggregates which can be derived from waste that is already being deposited? Can we augment the properties of the existing waste such that you can incorporate them as aggregates? So in this aspect, several research is being conducted in this presently. So, but there is it is a long way to go, but several people have started working regarding this. So there are several people are using rubber wastes and uh, construction and demolition waste itself are being recycled. So in this aspect, several uh, approaches are being taken by several researchers to meet the standard for augment the material to the standard that has been specified for construction purposes. So that is all I can say from as a research scholar. So I may not be able to answer your entire question.
No, it's general questions. Anybody can answer, or even it can be discussed further also.
Yeah,
After you can have some interaction with your team. You can also once again you can answer, no problem.
yeah,
Because we are seeing this one everyday life to day to day life. After some generations, 1 or 2 generations, it is very difficult to show the kids also where is the hill, how hill looks, or something like.
that is uh, that is true. But it is not that discussions have not started yet, but it has been started and people are working on it. So uh, we should hope for the good.
Okay, sir. Done.
So coming to the next question, the process that leads to the formation of soils from the parent rocks. Option A, weathering. Option B, withering. Option C, transportation. Option D, none
Sir,
of
we
the
are
above.
we are not able to see your slide, sir.
Okay, just
Move,
a
sir.
minute.
Move. Just move.
It's
Slide
not
is okay.
showing to us.
Yeah. Move, sir.
Yeah. Now,
Yeah. No,
Yeah,
it's okay.
now is it okay? It's okay, sir.
now,
Yeah, it's
Okay,
okay,
sir.
sir.
It is okay.
yeah. So the process that leads to the formation of soils from parent rocks are weathering, withering. Option C, transportation. Option D, none of the above. Yeah. So it
Option
is
A,
a
sir. Weathering.
fairly straightforward question. So weathering is a process by which the soils are formed, and even some of the rocks are formed by several processes that takes place. But weathering is the process by which soils are formed. Some rocks get converted due to several physical and chemical changes or thermal changes also. So that will be studying the rock cycle, which I will give a hint upon. So but from the parent rocks, it is essentially the process of weathering, which is why the soils are formed. So it is option A. So next question is, what type of stresses lead to the weathering of rocks?
It is, sir. Option D.
Option D and both physical, chemical, thermal. All the above.
So saying the correct option is fine, but uh, I would like to know from you uh, what is uh, can you give some of the situations where physical stresses or chemical stresses or thermal stresses which leads to the formation of soils? Uh, First we come to physical stresses. What type of physical stresses that leads to formation of soils? Anyone?
Temperature changes. Sorry.
Temperature changes is
Sorry.
thermal actually.
It is wedging of the ice or something. Abrasion.
Abrasion is
Collides
physical.
of some rocks, collision of some rocks,
Okay.
by it can done in a physical, observed in a physical weathering.
Okay. Any others?
What about plant roots?
Yes, that is also physical.
Erosion, sea coast. It
Erosion
comes
is
physical or chemical, both, no,
erosion is
sir?
physical.
And
Uh,
also The
wind.
recent question in week two, there was one question. I don't want to open it. In that, seawater effect on some stores they have given.
Okay. Yeah, yeah.
That it comes as a chemical as well as physical. So
That is
physical means it's like erosion.
that will be chemical.
Yeah, spraying of the water, seawater.
Yeah. So that we will discuss in the subsequent week.
Hmm.
So here physical essentially is wind, uh, and if you take in some cases gravity,
Hmm.
uh, and in some cases it will be abrasion or attrition due to water flow and everything. And if you come to chemical, chemical is essentially the if while the rocks come into contact with water, the water may or may not be pure. So there might be some chemicals that are present in some chemicals that are present in rocks which might react with those minerals and disintegrate it. So that comes under chemical. And thermal is exfoliation. So what happens in if for example in deserts, if you take or not in deserts, in high temperature region where we have a large temperature difference between day and night. So within the layers of the single rock itself, there will be temperature variations. So the increase in temperature causes expansion, and decrease in temperature causes contraction. So this leads to this cycle of expansion and contraction will lead to the disintegration of rocks. So that is thermal. And one more example of thermal stresses is in cold regions. If the rock pores of the rock contains water, and in cold regions the water tends to freeze. So in that case, water expands, and uh, subsequently it will uh, crack the rocks, and that also will lead to a weathering of rocks. So that also comes under thermal effects. So so these all the three individually uh, or as a coupled phenomena, it can contribute to the weathering of the rock. So either one can occur, or combination of one or two or three, that also can occur. So our option will be all of the above.
Sir, can you give example for biological?
Uh, Biological, I would say uh, it is uh, how to
Organisms,
yeah. So if you take
microorganisms.
yeah microorganism, if you take for example peats, they are not essentially
Sir,
they are not essentially formed from rocks, but those are organic decomposed organic matter which over a period of time disintegrates and further results in the formation of a type of soil. So that is an example for biological activity.
yes, sir.
Sir, here I have a little bit interaction.
Yeah, please.
In both the questions, let me complete
Yeah,
the
yeah,
sixth question only first. Do we have
yeah,
any
yeah.
evidence in any source? Because I don't know, I want to know it. That's all. In
Mm-hmm,
any source, as
mm-hmm,
per your knowledge, or maybe beyond also,
mm-hmm.
you can clarify me further.
Yes.
If you take only these three ABC,
Mm.
out of the total soils what we have in the entire world,
Yes.
which soil will be dominatingly weathered by either by physically or chemically or thermally? Any evidence in any sources which
Uh,
contributes major or which contributes less or something like that?
yeah. So it is a good question, but as of now, I don't have the answer.
Yeah, it's okay, sir. No problem. I am
So
not insisting immediately.
yeah, yeah,
If you find some other time with interaction, because we cannot interact with the directly with the Dr. DN Singh.
yeah, yeah. I know.
So you have a chance of everyday meeting or weekly and clarify and sometimes later you can
Sure,
answer.
sir. I will look into uh, some sources also. Is there any evidence for this for your question? So
Yes, sir. And sometimes the answer will be variable, depends on country also. We don't know if in our country, if chemical weathering is dominating, some other place, other may be dominating. That also will be there.
yeah,
I'm not sure exactly.
so that depends on various factors. So
Yeah.
to the best of my knowledge, maybe as a whole it may not be present, but as far as some uh, regional wise, there might be
Hmm.
some evidence what type of weatherings and
Dominating or something.
are dominated. So,
Hmm.
uh, but I will check and let you know. Sure.
Okay, sir. Fine, sir. No problem.
So the next question is, it is soil that remains at the place of formations. Are you able to see this
No, sir. No,
slides
no.
only?
Please go to sixth slide.
No, sir, no.
Just a minute.
We are in five now. Yeah, now it's okay.
Yes, sir. It's okay, sir.
Oh. Now, soils that remain at the place of formation are defined as.
Residual soils. B, sir, answer. Option B.
Yeah. Option B.
Option B, residual soil.
Fine. So, uh,
It's
do
also
you,
sedentary soil.
yeah. So, do you have any examples for transported soil?
Majority of the soils are transported, sir. Majority, like alluvial or aeolian, lacustrine soil.
Talus.
So, uh, then let me frame the question like this. What are the various transporting agents? Maybe that will be the next question, maybe.
Wind,
Okay.
gravity,
Yes.
glacier,
Gravity.
Hmm.
glaciers,
Yes.
What?
and water,
Hmm.
and also sometimes
Marine.
combination also.
Yeah.
Lacustrine marine, sir.
Yeah, that is obviously water.
And to minor extent,
Sir.
now even man, and to minor extent, it is microorganisms.
Yeah. So that is those are the transporting agents, because right
Agents.
now
Yes,
um, uh, humans have also become a major transporting agent for soils.
yes,
uh,
sir.
and obviously water, uh, wind,
Wind.
gravity. So these are the some of the transporting agents, and residual soils are broken down. Essentially, those are products of chemical weathering. So, for example, if you take uh, the west coast, we have a large extent of montmorillonite or black cotton soil, right?
Yes, sir.
So, yeah, in layman terms, it is black cotton soil. It is a residual soil where essentially it is due to the chemical weathering of basalt. So that is one of the examples. And if you even in regions like western coast of Konkan, Maharashtra, so those are essentially consist of laterites and basalt. So the soil that are formed are essentially due to the chemical weathering of those. So that is one of the examples for residual soils. And moving to the next question.
Sir, can I interact, sir?
Yes, yes.
You don't mind, sir, if I ask questions?
No, no, it is essentially
See,
the
I am
purpose of this.
interacting. I am interacting to know it. It is
Yeah.
not to check whether you are answerable or not. That is not my aim.
Ah,
I want to get the answer somehow.
yeah, yeah. Tell me, please.
Yeah. So what is my question here is why they are sedentary? What is the reason for that? Transported soil, we have, for example, water is there, media it will carry from one side to other side. That
Yes,
is because of topography or something.
yes.
Wind is the reason with the different speeds, different particles will be moved with the wind, not all particles.
Yes.
But why is it this sedentary soil or residual soil? What makes them to stay only in one place? Why they don't have a wind? Why they don't have water? What is the reason for that?
Actually, what happens is that uh, uh, the answer is in your question itself. So
Hmm.
it depends on the to the extent of weathering that has taken place, right? If some there are some type of soils which are which cannot be carried by water or winds or any external mechanisms. So maybe their volumes are huge, and also these residual soils do not exist stationarily. So in either way, there will be see if you take a layer of soils, so the single soil layer will be how much of meters? So there will be continuous weathering and transportation that will be taking place, but this to understand it as a separate entity, we have classified as such. That is the major reason.
Okay, okay.
Yeah,
You have some separate sources for the residual soils, huh?
yeah, there are
Separate.
separate sources. As I mentioned, uh, if you take peat is a kind of residual soil, and as I said, chemical weatherings essentially results in large uh, large extent of residual soils. Uh, so for example,
Oh,
basalt,
yeah,
it
yeah.
results in Montmorillonite and clay minerals similar to in that family. So these are some of the examples.
Okay, sir. Okay, sir. If you find any article or something, any source exclusively for residual soil, just pass on, sir. We'll go through
Sure,
also further.
sure, sure.
Thank you, sir. You can move.
Any others? Any confusions or any doubts you want to get clarified?
And here there was one more, sir. Delta.
Yes.
In further class, some other time you can little bit clarify what is delta.
Okay, sure. So, any other questions, or can we move to the next question?
We can, sir. We can move to next question.
Okay. So, which of the following is not a transporting agency for the soil? That is, to a large extent, that is dominating transporting agency. That is the context for this question. So,
I think microbus.
yes,
D. Option D.
yes. Water, it is obviously it results in alluvial deposits, and wind is aeolian deposits,
Aeolian.
and third is gravity. How what is the name given to soil that are deposited by gravity?
I think it is a colluvial.
Colluvial. Yes, sir.
So it is colluvial deposits. Colluvial,
U.
COLLUVIAL.
Sir.
So colluvial deposits are essentially due to gravity, effect of gravity. So and in this among the four, the least dominant agent is microbes. So microbes mostly form uh, play an important role in formation of residual soils. So the decomposition of organic matter, calcite precipitation, and those are uh, some of the activities which results the uh, which are dominant uh, but it is in case of it it results to a large extent of residual soil. Hope I'm clear. Any confusions, any doubts? Shall we move to the next question?
Fine, sir.
Yes, sir.
Okay. So question 9. So which of the following soils are predominant in delta and plain regions?
Can you
The
move?
slide is not visible to us, sir.
Just a minute.
Move to 7 slides. Yeah.
So which of the soils are predominant in delta and plain regions?
Residual.
Okay. Any other? Why residual?
Why? Because it is the plain in the plain areas. There is no option to transport the soil
Okay. What
due
happens?
to I hope.
Okay. Okay. Let me give you a situation. So there is a river which comes from a hill
Sir,
and it enters a plain, right? So what happens in that case?
right.
What happens when a river enters a plain? What happens to its velocity?
Velocity and turbulence both will reduce.
Velocity.
Reduces.
It reduces, right? So
Turbulence also reduce.
in that case, the water is getting what uh, imagine uh, 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 a stream that is starting from a hill and it is coming down and it is widening its course and it is becoming a river and it is carrying lots and tons of sediments along with it. So when the velocity reduces, what happens?
Can be sedimented at that place only.
It will be deposited, right? So
Yes, sir.
obviously the it is essentially due to that process deltas are formed. So it is a lot of silt sized materials that are being carried by the river that are deposited in a particular region. So in a form of a delta, that is uh, because of which we are terming these regions as delta. So essentially it is a transported soil.
So can you explain regarding delta, sir? And I mean, I think it in the at the particular place it will be rising portion. It may forms. Is
Yeah.
it
So people may
around
ask,
that the
yeah. See, delta are essentially formed when not when due to the deposition of silt, that is silt size particle that are being coming that are coming along with water, right? For example, we have Krishna Godavari delta, Kaveri delta, and in northern India.
oh, okay, sir. But when we call as a delta, sir, what I'm asking is when we call as a delta.
So delta is essentially a piece of land that are surrounded by rivers, uh, a piece of land that are formed due to the deposition of the uh,
Okay, okay,
that are formed due to alluvial deposits only.
sir. Okay, got it, sir.
Yeah. So any other questions or any other doubts?
The soil which is say deposited in a particular area because of reduction in the velocity,
Yeah.
will it not again increase the velocity further due to floods or any when the once again in the river
Yes,
when the
yes,
water
yes,
becomes
it
more.
happens. It happens,
So
but
that
what is the frequency of flooding? Maybe it occurs yearly once, but the deposition takes place all over the years, right?
okay.
And
So it deposits and again it will move.
yeah, yeah, it
Okay,
will be
okay, done.
moving. And if velocity, and also uh, it depends on the size of the particle also.
Yes, sir, that's correct.
So you might have uh, uh, people who have studied have some exposure to fluid mechanics, based on different particle sizes, or when you drop uh, uh, or who have done some lab courses, they might know hydrometer analysis, why we do. So you
Yes.
will be studying the exact application of this during the test. So it depends on the
Mm, mm.
that how many of you have studied Stokes law?
Yes, sir, in fine grained analysis we have.
So Stokes law, and also Stokes law comes in 10 plus 2 physics also. So
Sure.
the
Mm.
deposition of if you drop a solid in a column of liquid, its deposition depends on the particle size as well as its terminal velocity,
Yes, sir.
right? So that is the that is one of the applications.
Mm.
So now going to the next question, which of
Sir,
these yeah,
Yogendra sir, small questions are here
yes,
because I am keeping this question. I want to clarify even from the last semester, but I could not do that now.
okay,
Let me pass on to you.
okay,
This question number 9.
yeah,
There are two soils. Soils will be classified into either residual or transported.
yes,
From geotechnical point of view, as a geotechnical engineer,
mm-hmm.
either we are going to recommend the residual soils to use more or transported soils to use more, which is better for us. Equally, we want to treat them as a friends, or
Okay,
what way?
uh,
For example, we are using various purposes, various soils.
mm-hmm.
For example, if you have option of both the soils are available in your hand,
Yes.
which material we have to prefer for a particular infrastructure project?
So that depends on what is the application that you are looking for. So the answer cannot be objective. So
Yes, sir, I understood.
if you see, for example, if you take at a particular location, so
Hmm.
consider this as a uh,
Residual soil, we have mentioned already two example. One is black cotton soil, another is lateritic.
yeah. So
A
now
residual black. Hmm.
transported, if you consider this as a river which is
Hmm.
flowing, all right.
Yes, sir.
Now some uh, its velocity is fairly constant, right?
Yes, sir.
For our assumptions.
Hmm.
Now, if you take at a particular location in this region, it is
Hmm.
it is getting some particles are getting deposited here,
Hmm.
right? So I am just demarcating like this. Now, since the velocity is same, the size of this particle, what is your comment on the size of the particle?
When velocity is same,
Ah,
it is uniform.
it is uniform.
Yeah.
So if you are to if you consider for any as far as soil is
Filters and other application, we can use them.
it will be useful, but
Yes,
if
sir.
you
Definitely.
consider as a foundation material,
Hmm.
then its aspects will be different, which I don't
Yeah,
want to
but
go
still we can use it, sir. Transported soil, actually, from my side, from my view, transported soil we can use in different applications.
yeah, we
But
can use
this,
it, but
hmm,
relatively, see, my point is what I meant to say was since
hmm.
their uh, distribution, that is, the particle sizes are same, they are poorly graded.
Yes, sir.
So in some applications we may not prefer poorly graded sands.
Yes, we need a blended material. Compaction, we need a blended.
Yeah, so that is the reason. As far
Hmm.
as your question is concerned, the answer cannot be objective. So we cannot say outrightly that we prefer residual or transported, and also we also uh, we should also consider what type of soils based on mineralogy also.
Hmm.
So that also comes into picture, and several other aspects come into picture that needs to be uh, taken care before using this particular type of soil for a particular type of applications.
Okay, okay. Yes, sir.
Any other
Actually, for
questions?
Sir,
consultant
excuse.
normally will have a lot of challenge in this.
Yeah, and if you take, for example, this uh, alluvial deposits, they are more
Hmm.
prone to uh, earthquakes.
Liquefaction. Yes, sir. Yes, sir. Earthquakes and
So
liquefaction.
you will be studying those who don't. Many of them are students here. They may
Yes,
not
sir. Yes.
understand. So
Okay.
when we come to those weeks, we can discuss.
Fine, sir. This is a preliminary question only.
Sir, I have one doubt, sir.
Yes.
So, in the residual soils means even though it is separated from the parent rock, it is deposited at the parent rock itself, right,
Yeah.
sir?
Yeah.
So, even means after separation of the from the parent rock, why it is deposited itself there, sir?
That means whatever the transporting agents are there, uh, uh, they are not dominant to such extent they can transport them. That is the only reason.
Acha, okay,
Mm.
okay,
Okay.
right, sir.
Right, sir. You
So
can move, sir.
moving to the next question, which of the following types of soils fall under the category of ultrafine particles? So sands, clays, gravel, and boulders. Any views?
B. B, sir. B.
So what do you mean by boulders?
Answer is clay.
Yes. So ultrafine particles are clays.
Yes, sir.
So uh, what is meant by boulders?
Sir.
The
Bigger
particle
rock.
size is differ one compared to other three options.
Means the particle size having greater than 80 size, then we call it the boulders.
Boulders. So the this classification is based on
Size of the
size of the particle.
sir.
So essentially, if we classify boulders are large chunks of rocks. Uh,
And it's more than 30 centimeter.
yes, 300 to 300 mm, 80 to 300
Sir, for
mm.
ninth question answer, wow, as we are discussing, answer is A, but you are ticking, you are given tick mark for B option.
No, no, it is B only, transported only. They are only for predominant in delta and plain.
After transportation, when this is favoring in particular area, they deposit.
Yes,
That is called delta.
yes, yes.
Acha, acha. Okay, okay, sir.
But the soil that is getting deposited is transported from one place to another.
Sir,
Okay. Yes. So boulders have 80 mm to 300 mm,
sir. Yes, sir.
and sands sands are less than 4.75
MM.
mm, and clays are
Clay is
essentially
less than 2 microns.
less than 2 microns.
Okay, gravel is 4.75 to 80
Yes, more than 4.75, between 4.75
Yes,
and
sir.
80. So it is purely based on sizes. So, and right now, this is sufficient. As we go deeper, we will understand what is the difference between clays and clay size. These are clay size. Ultrafine particles are clay size. So there is a difference between clays and clay sized particles. Okay, that you will be learning in further in coming weeks. Hope I am clear.
Yes, sir.
So the answer is clays. Any questions? Any queries?
No, sir.
So let us move question 11. So what distinct properties of the soils differentiate them from other civil engineering materials?
So next slide, sir.
Just a minute. What distinct property of the soils differentiate them from other civil engineering materials? Option A size, option B strength, option D shape, and option C memory.
Strength. Option B strength.
No, here you need to understand the question. See, there are some properties which are common for all civil engineering materials, but soils have one peculiar phenomena which differentiates them from other materials. That is the crux of the question.
Yeah,
Memory, sir.
it's memory, sir.
Yeah, it's memory. So I will uh, coming to the first option size. You have any civil engineering materials you define by size, and strength. If you take concrete, steel, uh, uh, any other construction materials, wood, it is you define strength. Even soils you define strength, and shape obviously it comes into picture. But the peculiar aspect is memory. Why memory? Are soils intelligent? What is your opinion?
Little extent, Dr. Singh sir already covered about memory, about nano silica and other materials,
Yeah.
but not enlarged.
Okay. So, can anyone think of why? What does memory in this? Uh, what does memory in this context mean? Why? How do can you think of any uh, phenomena the where soils possess memory? Memory in the sense,
Means
uh,
its properties.
so I will give a brief uh, insight to this. So the soils is there are certain type of soils which behave differently when you subject it to different type of external load with time. All right. Am I
Yes,
clear or am I confusing?
yes, sir.
Yeah, please.
So, for example, if you consider a layer of soil, and what happens is, let us consider a point here, and we are considering the behavior of the soil here at this point. So there are two possibilities which I would like to give. So, and here the amount of uh, what to say, uh, the the soil is subjected to this much of soil layer above, right? Some H. Understood? Any doubts? Any? Uh, are you able to follow?
Your pen is not showing anything. Are you writing or you are not writing?
Okay, just a minute.
Yeah, that's why we are, now it's okay, sir. Only cursor is moving previously. Now it's okay.
Okay. So, so now you consider a layer of soil like this. Just a minute. Are you able to see now?
Yes, sir.
Is my pen visible?
Yeah,
Or
cursor is visible. Yeah, it's also visible.
so so let me start from again. You let us consider a layer of soil. So and you consider a point here where a point is of our interest. So what happens is that there are two situations which I would like to give. So one is you add an extra layer of soil here, right? That is one situation. You add extra amount, some X. And second situation is you remove a particular amount of soil from the existing thickness.
Sir, again same problem, sir. What you are writing, we are unable to see. Only cursor movement we can see.
Okay,
Already you have shown ground level, height h, and something.
okay, just a minute. Ah, now, now is it visible?
Draw it, sir. We will see it. Draw it, some line or something you draw it. Cursor we can see still,
Okay,
but what you are drawing is not visible.
okay. So this is the layer
Yeah,
which I
now
was
it's clear.
talking about.
Now it is
So
clear.
we are considering a point here,
Okay, sir.
and it is at a, let us consider a H. And what I am saying is, I will give you two situations. So first situation is you are adding a particular layer of soil above it. It is, let us say, X. This is first situation, right? So listen carefully. The second situation, what I am giving is that we are removing some amount of soil from the existing thickness, right?
Okay, sir.
So uh, uh, as of now, please, those who are in the those who are students and who are new to this course completely, so please just listen uh, for the time being, and you will be you will be able to relate it more when in towards the end of the course. So if you consider the same point and you subject it to some testing, the behavior of the same material under this different type of situations will be different. So there are some type of soils which uh, which records what type of loading it has undergone in a previous uh, during its earlier times. So it's uh, the response you get from these type of soils will be according to that only. So you can understand what this particular soil has undergone in the past years, such that it is behaving like this. So that is the unique aspect of soils which differentiates from other materials. So that is the thing we term it as, we call in a layman's language as memory. Hope I am clear. And if I am not clear, you please uh, uh, don't worry. You will relate it more as the course progresses. And coming to the next question, which of the following is not an engineering property of soils? Hello, am I audible?
Caesar, Caesar,
In
So,
vertical size.
strength. If we come to the options, strength obviously is a engineering property. Is an engineering property. So permeability is an engineering property. So particle size
Index.
is an index property. It is an index property which we use to classify them. And consolidation is also an engineering property, which is a time dependent phenomena which alters the uh, uh, strength properties of the soils, or which alters the uh, uh, thickness or voids, several aspects. It will the this phenomena this property will alter, and it will take lot of, it is a time dependent phenomena. Over a period of time, it will not occur in us immediately. It will take a lot of time. So so that is the question here. And moving to this, so what type of process is arsenic oozing out of soils? Is it a physical, is it chemical, is it thermal, or is it biological?
Option B, sir, chemical.
Yes. So it may not be a natural process, but now due to the several sources of contaminations of ground, we are experiencing this arsenic content, which are also present in groundwater in some of the regions of India itself. So which indirectly leads to several health hazards in that region. So but our focus here is these several, uh, uh, not only arsenic, there are several even salts that leach out of the soil, and in this due process they will alter the engineering properties itself. So and uh, but those are essentially chemical processes. Any doubts?
It's fine, sir.
Okay. So moving to the next question. Uh, Microbial processes in the soils leads to both deterioration and upgradation of soils. So what is it, true or false?
False.
It is true, sir,
Why is it true? Why is it false?
because it's helping for soil formation, and also it is using that as a source.
Okay. But what is deterioration? Where does it occur?
For microbial, food is going to be the soil, and the waste which is coming from the microbial is also soil, organic.
Yes. Okay. The other person who said false. Why is it false?
So that means the deposition of organic matter is called upgradation of soil.
Okay.
So which is leads to more deposition to make soil for formation of soil. So my point of view, the answer is false. So not a deterioration. Answer is upgradation, which my point of view.
Okay. But what does it do to the Strength of the soil.
According to the strength, comparing other properties, the microbial action leads to decrease the strength, right?
Yes, that is obviously deteriorating the soil, right?
Oh, that means deterioration, right, right. So answer is true.
Okay, where does it upgrade the soil?
I will check and think again.
Okay, so here deterioration is obviously it is due to the decomposition majorly, presence of organic matters or breaking down of existing uh, particles also. Upgradation is where uh, there are if there are two grains. Hope my writing is visible.
Yes, sir.
Consider two grains of soil that are present at a particular time, and as it is microbial process, there are certain bacteria present in it. Uh, just as a schematic, I am drawing it. Maybe it is not to scale. Bacteria will be very small compared to the size of the uh, particle itself. So when this bacteria are in contact with these grains, the excrete from this bacteria are sometimes they serve what to say, they excrete calcite from the bacteria excrete calcite, which forms a bridge between these grains separately. All right.
Yes, sir.
So in this case, the strength of the soils or the properties of the soils will be enhanced.
Because of binding nature.
Yes, and calcite is a binder, so it
Yeah.
will bind the grains together. So that is the reason microbial actions also can cause upgradation of soils, upgradation in terms of the properties, and this this phenomena is known as MICP. That is microbially induced calcite precipitation. Calcite precipitation. This is now being in some aspects it is now being used as a it is being viewed as a ground improvement technique also to enhance the properties of the soil. So that is the reason. So the answer is true. Hope I am clear. Any doubts? Hello. Any doubts?
No doubt, sir. It's clear.
Okay.
Sir,
So yes,
this technique is used only for coarse grain soil, no?
yes. Now it is used for sands only.
Only sands. Okay, fine.
Yeah.
Right, sir.
So coming to the next question, acid rains might be responsible for weathering.
Yes, true.
True, sir.
It's a
It is
chemical weathering.
it
No?
is leads to chemical weathering. It is true.
Yes, chemical weathering.
Okay. So coming to the third question, rocks can be formed from soils.
True.
Is it
No?
true or not?
True, sir.
No.
Is there any other
Yeah, maybe you
alternative?
transported some.
See, understand the question. So rocks can be formed from soils. We have
Sorry,
seen soils are formed from rocks. Can rocks be formed from soils?
I think so.
No, it is true because it's a geological cycle.
So
That's no
Yeah,
need for.
the yes, the sand dunes were formed by means of transportation of soil, right?
yes,
So
and
maybe a geological cycle, right?
this this will lead us to the concept of rock cycle. It is true. So I will give a brief idea of rock cycle and we will conclude this session today. So this is the rock cycle. So what happens is that uh, this is it all starts from magma, right? So when this magma uh, cools, that is, it comes to a uh, depth and temperature conditions where it starts to cool. It forms igneous rocks. And for example, examples are granite and basalt. Granite are formed by very slow cooling, and basalts are formed by very rapid cooling. All right. So this will lead to the cooling of magma will lead to igneous rocks. Now what happens is that due to several weathering agents and transporting agents, this igneous rocks over a very long period of time will be broken down and get transported to other places and get deposited as sediments. All right. So these sediments further over a period of time, due to further deposition of sediments, they get very hardened and they give rise to sedimentary rocks. So these sedimentary rocks are where our oil and gas is present. Oil and gas are present in these sedimentary rocks or sedimentary rock formations. All right. And subsequently, if you see, when igneous rocks, if there is a situation where it starts melting, it further it melts to magma. And in case of sediments and sedimentary rocks, it is a it is a cycle of process. Its deposition will will lead to formation of rocks, and further its weathering will lead to deposition of sediments. So it will be a cycle. And when these sedimentary rocks are subjected to heat and pressure, that is temperature and pressure, what is this process known as? It is known as metamorphosis. Metamorphosis. So that is due to the action of heat and pressure, it will form metamorphic rocks. And similar way, igneous rocks on further action of heat and pressure, they form metamorphic rocks. And for even metamorphic rocks, when they get weathered and erosion, they result in the formation of sediments. So this is where all the this is the cycle of uh, formations and degradation and enhancement that occurs in the nature. Hope it is clear. Any doubt?
Yes, sir. It's fine, sir.
So this cycle is known as rock cycle, and the minerals are essentially classified as siliceous rocks, which are dominant in silica, SiO2, and carbonaceous, which are dominant in carbonates, CO3 2 minus. Either it can be calcium carbonate, it can be magnesium carbonate, it can be calcium magnesium carbonate, anything. The argillaceous is which contains aluminium. Aluminium and silica, aluminosilicates. So those are essentially argillaceous rocks, which are clay minerals, pyroxene and feldspar and everything. So this is the fundamentals of rock minerals. So with this, the session for this week comes to an end. So you can always you can this this session is being recorded and it will be uploaded in YouTube, and its links will be shared with you in the NPTEL pages. You can go through anytime, and if you have any queries, you can ask in further sessions also. Uh, I hope this session was useful. So any feedbacks?
Yes, sir. A lot of knowledge we gained through this.
Okay.
Even through the recorded videos, we don't have a scope for asking a questions. It is one way.
Mm-hmm.
There also we are going to get some knowledge, and here also it will be good because here we have a direct live interaction.
Yeah.
So we feel much better compared with the recorded videos. This one.
Okay.
So that was wonderful, but still, we'll have a lot of questions will come to update.
Sure. Sure. Sure.
And my request is at the end of the session,
Yeah.
try to pass on any latest things which are happening, one or two questions
Okay.
which we have to search,
Okay. Sure.
like that question also, so that we spend some time on searching and get the answer.
Sure. Sure. Sure.
For example, you are mentioning about your research work on the fine grained material.
Mm-hmm.
What is that? Cosmetic materials and other pharma industry.
Mm-hmm.
We don't have any knowledge. For me, I don't have any knowledge on that from geotechnical point of view.
Yeah. Yeah.
And if you show some equipment, what you are doing in laboratory, how it is, what test it is, we are further happy to see that.
Sure. 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 And in this regard, I would like to uh, I would like to say uh, there is a course offered by Professor DN Singh himself. It is known
Yes.
as Environmental Geomechanics.
Okay.
So if you go through that course, it will be more of a research oriented and latest developments and the techniques, several advanced characterization techniques that has been uh, used for uh, uh, research purposes, and uh, as far as your question is concerned, you can gain more
Okay, sir.
insight to
Understood.
it. Yeah.
Understood. Understood.
So it
Okay,
is
sir.
also available in YouTube. You can go through that also.
Fine,
Uh,
sir. Thank you. Thank you.
so I'm winding up the meeting. It was nice interacting with you. Thank you.
Thank you, sir. Thank you very much. Thank you, all of you.